Hello, welcome back to Geothermal Prospect Evaluation course. For this week, we will discuss the aspects of drillings and well evaluation for geothermal potential. This is usually completed after we have finished the 3G evaluation and we would like to know where to drill and the extent of our drilling process. I am pleased to share with you the presentation material prepared by an esteemed guest lecturer in 2019. He is a well-site geologist. He has dealt with various drilling in the industries. To start off, we would like to understand the purpose of drilling and the importance of drilling, especially in geothermal industries. The purpose of drilling is to collect and proof data from the subsurface. The goal is to turn data into information and from the information into insight. The drilling stage in geothermal exploration is usually conducted after we have done the surface survey or the 3G survey. Based on the 3G conceptual model, we can determine where to drill and how deep we should drill. The drilling target is usually deduced from the conceptual model that we have built throughout the 3G data preparation. Geoscientists will then determine the depth of the drilling and also select the casing in order to ensure that the drilling is in the right position and has the correct strengths. After we have completed the drilling, we complete a thorough analysis on an on-depth alteration analysis. This is done for us to gain a physical and chemical properties of the rocks. Thus, we can understand the properties and also the type of the geothermal play that we are dealing with. The purpose of drilling in geothermal well is to determine where the heat source is, the permeable reservoir, the supply of water, the overlaying of impervious rock, and also the reliable recharge mechanism. This is in line with the purpose on making a conceptual model. Therefore, drilling is actually just a confirmation on this conceptual model that we have built prior to the drilling process. If you all are wondering, geothermal drilling is actually quite similar to the other types of drilling. It's quite similar to the petroleum drilling. It basically uses the same rig, the same tools, and the same supplies, and also the same safety measure. But the difference between geothermal drilling and probably the other drilling, such as the petroleum drilling, is the nature of the reservoir. Usually when we do geothermal drilling, we deal with a hotter temperature in the subsurface. And now we can move on to the drilling operation. To start off the drilling process, we should construct the rig for drilling operation. This is pretty much the layout for the drilling operation rig. It consists of the hosting or the drilling system, the power system, the safety system, and the circulating system. The power system of a rig usually consists of the big diesel electric engines. This is to ensure that the drilling can run properly while it's doing its job. These engines usually are made up of generators to produce electric powers. This power system is then connected to the hoisting system to ensure that the rig can move up and down as it creates the well to the subsurface. The second aspect is the hoisting system. These are the components of the hoisting system such as the derrick, the drilling line, the crown block, the traveling block, the hook, and the drawwork. It is usually made up of a metallic structure because of the strong type of materials. The derrick or the mast is usually in the shape of pyramid because the pyramid actually offers a good strength to weight ratio in order to support the drills that is going up and down into the subsurface. Within the derrick, we usually can find the drilling line or drilling cable. The drilling cable is a wire rope used to support all the drilling equipment which needs to be run inside the drilling hole. The cable is usually rotated in a drawworks located in the rig floor. This is an example of a drilling line, the traveling block, and the hook. The drawwork consists of the machine based or located on the rig floor that is made of a large diameter steel spool brakes and a power source in order for us to ensure that the rotating motion can be run properly. The cable is run downward from the crown block and is wrapped around the drawwork spool. The main purpose of a drawwork is to actually reel up the cable, ensuring that the hole and the drill can run smoothly while you're actually doing the job. The rotating and drilling system actually consists of rotary table, Kelly system, top drive system, and drill string. First, we would like to discuss the Kelly. The Kelly is a long square or hexagonal steel pipe and is used to transmit rotary motion from the rotary table in order for us to actually turn the drill. It helps to ensure the motion is actually going around or in the correct motion. It also helps for us to lower or elevate the drill string after we have finished with the drilling process. In some modern rigs, the Kelly is actually being replaced by the top drive. The top drive system consists of these components right here, the traveling block, the goosenecks, the connection, the bales, the elevators. It actually helps to drill with 3 pipes in one go. Another part of the drilling system is a drill string and drill pipes. We actually installed this drill pipe and drill string as we drill the hole or the well. The combination of the drill pipes and the bottom hole assembly, such as these components right here, actually can help you to turn the drill bit as you turn at the bottom of the well. Because usually when we do geothermal drilling, we don't actually drill vertically. However, we need to drill vertically and then laterally. After that, we can then install the drill pipes to ensure the stability of the wells. Geothermal wells actually deals with a much more harder lithology consistency than other petroleum system. We need a proper drilling bits. Usually the drill bits consist of the roller bits and the diamond bits. To ensure that there are holes that can be punched through the lithology made of the intrusion or igneous rock, we use the diamond bits. This is it's actually quite cheap, but the most expensive part is actually the diamond used in the bits here. And what an unfortunate event is when we're actually doing the drilling, we lost the diamond because of the hardness of the host lithology. Alternative to the diamond bits, we can use the roller bits or tricone bits. It has 3 conical cutters, so it has like a 3-shaped cone right here. This is used to drill soft formations or even hard and abrasive formations. The tricone bits actually helps to destroy the rock by compression. It's quite mobile, so it's quite flexible. Therefore, it can provide you better cuttings of the well core after you retrieve the corings. To the next aspect of the well rig, we have the circulating system. This circulating system consists of the drilling fluid or the drilling mud, the mud pits, mud pumps, the flow line, the shale shakers, and other equipment that supports the circulating system. The drilling mud actually ensures that there is a fluid that can help lubricate the drilling process. Usually the lubricate fluid is the mud in the form of a mud, which consists of clay, usually bentonite, or even water-based or oil-based diesel fluid that is actually circulating through the well. Let's say this is the well and we have the rig here. And usually it's circulated with the mud to ensure that the drilling can run smoothly. The main functions of the drilling fluids are usually to clean up the bottom hole, also to cool and to lubricate the bit, so the bottom part here, so it doesn't get too hot. It helps you to deposit the mud cake on the walls to prevent fluid loss during the well drilling, to actually help prevent the collapsible strata in case we have an unstable strata in the subsurface due to some introduction of water and the puncture of the intrusion rocks, and also to help to maintain the subsurface pressure and to avoid blowout. Of the drilling rig is a safety system. The safety system consists of the blowout preventer or the BOP, the choke manifold, the kill line, the choke line, the mud gas separator, and also the flare line. The blowout preventer, usually the common type of safety system, is actually consists of the valve that is installed at the wellhead to actually prevent you from a blowout pressure. Because sometimes when we complete the drilling, we cannot maintain the pressure, so therefore this is the function of the blowout preventer. The BOP also helps you to stop different fluids reaching the surface when we are doing the drilling, especially when we are doing the well testing, when we are still currently developing the well and not understanding the condition of the well of the subsurface quite yet. After we completed the well drillings, we need to report the information that we obtained from the corings and also from the well drilling process. Based on the geological information and the drilling, we then compare the lithological description and interpretation based on the geological mapping and the corings analysis. From there, we can deduce the reservoir and the fluids characterization based on the corings. And also, we can actually determine the alteration and depth. So basically, from drilling information, we have these data as the inputs, the MWD, the logging wireline, the mud logging, the coring and testing, and then we can create a report, comprehensive report on the subsurface to cross-check with the conceptual model that we have built. The examples of the report that a well site geologist must complete after they have done the drilling process. First, we need to describe the lithologies, such as the name, the color, the hardness, the texture, etc. We then can determine the categories of rocks, whether it's siliceous, argillaceous, carbonates, or etc. And then we can describe the physical and the chemical properties of the rock based on the analysis that we have completed on the mud log, the corings, and the sample description. The geoscientists then complete the geological report to be reported back to the team and to be cross-checked with the conceptual model that we have built. Based on the mud logging, we then can also retrieve this type of data of the subsurface where we can determine the alteration and also the lithology in each depth. This is very important for geothermal exploration because from this information, we then can determine where the clay cap is, where the reservoir is, and where the possible heat source is. From here, we can also determine the characteristic of the rock, such as the permeability, the saturation between fluid and steam, and the densities of the rock. Of the corings that can be retrieved after drillings. We can see here that the corings are mixed up with the mud, and after being washed, we can then retrieve the proper corings for analysis. When we do geothermal drilling, it's quite similar to other drilling, such as the ones in petroleum. So we use the drill bit, the drilling fluid, we also use the mud pump, and we use the vane. We usually use the tri-cone roller bit or the diamond bit to make a hole and puncture the lithologies in the geothermal system. So here we can see this is the hoisting, the derrick and the mast, and this is the rotary table. This is where the drill is actually going down into the well. This is the drill pipe, and this is the bit, and we install casing as we go down the depth. To ensure the running of the drilling, we then use mud, and the mud actually circulates around the mud pit and the reserve pit. The running of the drilling is ensured by the power system, usually use the engine here, to run the drills up and down. Here is the cross-section view of the geothermal well drilling. As we drill down into the subsurface, we install casing. At the beginning, near the derrick and the mast, we install casing with a quite large diameter, usually a 26-inch hole with a quite strong or larger anchor casing of a 20-inch. And then when we hit the first aquifer of groundwater, we then decrease the casing slowly, and then as we reach the steam zone, we then change casing again, and as we reach the production zone, we use a smaller casing in diameter. Usually when we have reached the reservoir, it is when we reach the steam field fractures, so we reach the zone where we have the highest possible permeability. And here we use the smaller diameter in casing to ensure that there can be a pressure difference between the subsurface and the pressure on the surface. Because when we have pressure difference, it can help you to bring the water from the reservoir to the surface. At the end of the drilling process, this is what we will have: a series of data corings in each depth, in different depths. We then can determine the zone of alteration, the location of the clay cap, the exact location of the reservoir, and also the possible heat source and the possible recharge mechanism. So that is actually the purpose of a geothermal drilling. And if we are satisfied with the drilling process and the drilling results, the information is then brought up to the team again to ensure whether we need to drill more holes or we should stop the exploration because maybe the system is not feasible to be explored further. However, if we are satisfied with the results, we can then continue with the drilling process. We could add more drilling wells depending on the CAPEX cost that we can obtain for this certain project. After that, we can complete well testing to ensure the output or the debit flow of the hot water that can be produced in a well. So that wraps up the drilling and the well evaluation topic. I hope you have a lot of questions to be asked. Thank you for your attention, and I will see you in the next topic.